Hello dear engineers. In the previous video, we have briefed on how an ID can be configured to publish GOOSE messages, and we demonstrated that on CMC 356, and we showed how that can be done and be verified. In this video, we're gonna use the knowledge we learned so far to do practical testing for the MiCom P645 overcurrent element. We're going to test the pickup, drop-off, and timing using the CMC 356 test set. We have done some settings for the MiCom to pick up at 1000 amps primary. Before we can proceed to that test, we need to configure the MiCom P645 to publish GOOSE messages. Let me show you the concept diagram where we're going to see clearly what we're going to do. So here, the test set going to inject through sampled values a current to the MiCom relay. And we're going to start increasing that injected current until it reaches the pickup of the relay. When the relay overcurrent element start picking up, we're gonna capture that as a GOOSE message. So we need a GOOSE message represents the start of overcurrent element. At the same time, the test set will keep increasing the injected current until it reaches the trip. When the relay trips, it's gonna send a GOOSE message to the test set to stop the test. So let me show you how that can be done. From S1 Agile software that we use to configure the MiCom, we can go to the IEC 61850 configurator to configure the GOOSE messages. So in the dataset definitions, we define these data attributes here to be sent on a GOOSE message. So as we can see here, we configured these data attributes. When the overcurrent element starts, it's gonna send this GOOSE message. So this GOOSE message can change from 0 to 1 to represent the start of the overcurrent element. When the injected current exceeds the pickup value, then the relay trips. Then this GOOSE message gonna change its value from 0 to 1. And we're gonna configure the test set to subscribe to those GOOSE messages. By the way, this can be exported as CID file that can be used to configure the test set. So after defining this dataset, then we'll define this as a published GOOSE message. And as you can see here, this is the GOOSE control box represents this set, and you can see the name of that one here. So this is the dataset reference that gonna be combined with this GOOSE identifier. So let me show how can we subscribe in the test set software to receive those GOOSE messages. So from the Omicron GOOSE message configurator software, we can import that exported CID file from this import files from here. Then it's gonna contain those GOOSE messages. So for the binary input 1, I subscribe this or represents that GOOSE message for trip. Binary input 2 represents the start GOOSE message. So let's go to do configuration for the ramping. We can use the test module called ramping in the test universe software. Let me show you that. So in ramping test module, we can configure different ramps here. So the first ramp for the pickup is going to start from 2 amps secondary, and the trip settings in the relay are at 2.5 amps secondary. We're going to increase this until 3 amps secondary, and then there's another ramp at the same rate. It's going to ramp down back to 2 amps second. So instead of trip to this test to continue, we're gonna use start. So we're gonna show us when it start. So let's start the testing using this ramping module. So just hit start, continue. So to assess the results of this test, we go to View, then Ramp Assessments. So the pickup for Ramp 1, it picked up at the settings at 2.5, but the actual 2.531. So the assessment pass, it is within the tolerance of this relay. For the drop off or dropout, it's gonna be used to be tested using the ramp 2, and it should drop off at 2.375 amps, but actually it dropped out at 2.344 within the tolerance as well. So we can say the relay passed the pickup dropout test, and next we're gonna do the timing test. So for that purpose, we'll use the Overcurrent test module from the Test Universe software. So following to the Omicron's Ohm's law, so we'll start with the configuring of the test object. For the hardware, we'll not do anything, and then we'll do the module configuration. But let us go to Relay Configuration Software S1 Agile to see the settings side relay for the overcurrent element. The function is IEC definite time, and the current set is 1000 amps. That's primary, which equivalent to 2.5 amps secondary, and the delay is just 1 second. So simply those are the settings in S1 software. Let's go back to the software. So let's go to the test object, then overcurrent function, edit. Here we see it is non-directional and the tolerances as laid out here. Then the elements, we have only one element here, which is IEC definite time, and the backup is going to be 2.5 amps and at 1 second. So the definite time is just 1 second. I did these settings just to show you the concept of this, but practically maybe things are different from what you see here. Then we OK this. OK. So for the characteristics test, we'll add a 3-phase fault. We can use 4.5. Then we click add. Let me close the report here. So we can pick up at different points here around the TCC here. Let's add another point here and say this is gonna be 2.6 amps. We have it here. Add another point, and let's do it at 3 amps secondary, and that's it. So let us test these points and see the results of this test. By the way, I put this third-party software to show the GOOSE messages when the overcurrent element starts. So let's start testing. So now it's tests the first point. Second point, you can see the GOOSE message here change. Okay. We tested those 4 points. So for the first one, we don't have pickup. For the second one, it's just exactly at the pickup, 2.5. So here you can see the relay took 4.451 seconds to trip. But if it's above that pickup value, it takes just 47 milliseconds above the 1 second. So within the tolerance for here is just 50 milliseconds, so plus minus 50 milliseconds. So within the tolerance for the other point. We can add this to the report, and that concludes this video. Thank you for watching.